When we gaze up at the sparkling firmament on starry nights, a fundamental question inevitably germinates in our minds. Are we alone in the universe? In view of the exuberant diversity of the cosmos, is it even possible that our Earth is the only planet in the universe that harbors life? Many experts answer this question with a decided no. And this, although so far no other celestial body could be categorized as clearly life-friendly. But even if the final breakthrough is currently still a little while in coming, this does not mean that astronomers have not already tracked down a large number of breathtaking exoplanets that could soon be included in the official list of Earth twins. Do you want to know which exciting contender has already been added to the star charts in this regard? And why, against all odds, TRAPPIST-1e might actually harbor life? Then please leave us a like and a subscription and stay tuned until the end. 5,303 exoplanets in 3,908 systems. Although experts have erased hundreds and hundreds of white spots from star charts in recent years, Earth's cosmic twin has always slumbered in obscurity. Despite all theories, liquid water deposits and favorable locations in space, proof of a habitable planet or even extraterrestrial life remains an unfulfilled research dream. However, for this to change one day, a celestial body must fulfill a fundamental prerequisite in order not to fall out of the theoretical life grid. Right from the start, it must draw its circles within the habitable zone of its own system. This means that it must orbit its host star in a distance range which allows water to exist on its surface in a permanently liquid form. As we know, the cool wet embodies an important condition for the development of Earth-like life. In the case of the exoplanet TRAPPIST-1e, the good news is that the celestial body, which is 40 light-years away from us, meets just this circumstance with galactic bravura. Located in the constellation of Aquarius and identified in February 2017, the extrasolar world orbits the dwarf star TRAPPIST-1. However, the celestial body is in best company as it belongs to a group of at least 6 other planetary members. At this point, one might ask how experts manage to detect unknown planets at all. On the one hand, we owe the discovery of TRAPPIST-1e to the use of the Spitzer Space Telescope, and on the other hand, to an equally appreciated and proven detection method known as the transit method. As the official name suggests, experts focus their attention entirely on planetary transit, that is, on the apparent passing of a planet in front of its parent star. Meanwhile, the planetary companion eclipses part of its central star. Once this phenomenon has been registered, experts have to check the brightness fluctuations of the star for regularities. In order to rule out random events, at least 3 transits with equal time intervals between them must be detected. At first glance, the chances of success in detecting an exoplanet using this indirect detection method seem anything but promising. But although the probability of observing a planet passing by a randomly selected star is less than 1%, the transit method has long been established as an astronomical guarantee of success. By 2019, a whopping 80% of all newly discovered exoplanets should be detected and confirmed using this method. In detail, however, the transit method is not only capable of revealing the mere existence of a celestial body, but also of revealing some of its fundamental characteristics. In addition to general statements about the orbital period and the radius, this also includes information about the inclination of the orbit, as well as conclusions about the distance range between planet and star. Spectroscopic studies, in turn, allow data to be collected on atmospheric composition, reflectivity, and temperature. With this information in mind, an exciting question arises. What details have scientists already been able to uncover about the supposed Earth twin? Basically, TRAPPIST-1e is listed within the astronomical world as an Earth-like planet. However, this official designation is somewhat misleading. In fact, it's generally applied to rocky planets with solid surfaces that have a roughly spherical shape. However, despite its reference to our terrestrial home, this definition does not take into account the potential habitability of a celestial body. With a radius equivalent to 0.92 times that of Earth, TRAPPIST-1e is slightly smaller than our blue home planet, The same is true for its mass, which is estimated at 0.7 Earth masses, with a somewhat lower density and a surface acceleration that corresponds to about 80% of the terrestrial one. The researchers determined within the framework of a theoretical calculation that the equilibrium temperature of the exoplanet amounts to 246 K, or minus 27 degrees Celsius. A short classification for better understanding. While our blue home planet is incessantly illuminated by the sun, it also emits energy in the form of thermal radiation. It is therefore in radiation equilibrium. If our Earth had no atmosphere, its equilibrium temperature would settle at a value of minus 18 degrees Celsius. Consequently, we have the greenhouse gases in the atmosphere to thank for the fact that life-friendly temperatures prevail on our home planet. And exactly in this circumstance lies the fundamental point, which must be still fathomed in the case of TRAPPIST-1e. Up to date, still nothing is known over the chemical composition or the possible atmosphere of the planet. In contrast to this large gap in knowledge, however, experts strongly believe that the celestial body, just like all other planets in the TRAPPIST-1 system, has a bound rotation. That means, while our Earth on its journey around the Sun constantly turns around on its axis, TRAPPIST-1e always presents one and the same side to its host star. As a result of this orientation, it is thus divided into two zones that could not be more different: a cold night side, which lies in perpetual darkness, and a significantly warmer day side, which is incessantly illuminated by the star. In view of these stark contrasts, one might think that the existence of life could already be categorically excluded at this point, but this is not the case. In truth, between these two worlds of extremes, a narrow, ring-shaped strip could be slumbering, which has medium temperatures, and thus also allows life to flourish. Beyond that, some scientists take the data collected so far, even to the cause of a fascinating speculation. According to it, it's conceivable that we have here a full-grown ocean world, as it already betrays this designation. Planets are meant with it, whose surfaces are completely covered by water. So far, however, no such celestial body should be confirmed officially. Indeed, with the exoplanets GJ 1214b, Kepler 62e and f, as well as TRAPPIST-1e and f, some exciting candidates exist. However, before the experts track down the first ocean planet, we must continue to make do with Kevin Costner's Waterworld. The future and the present of astronomical research is called James Webb. Although the most powerful space telescope in history has been in scientific use for less than a year, the spectacular images and groundbreaking findings already resemble a roaring success story. As is well known, the $10 billion instrument was to be developed for an ambitious purpose, namely, to revolutionize our understanding about the universe. To this end, the telescope, which was specially designed for infrared astronomy, will primarily take a look at those first luminous formations and stellar associations that were born after the Big Bang and during the so-called Dark Ages. In addition to the analysis of structure-forming processes in the cosmos and the study of galaxies, black holes, and protoplanetary disks, Webb will also devote himself to another, no less exciting field of activity: the study of exoplanets, their atmospheric composition, and potential habitability. TRAPPIST-1e is also among those fascinating celestial bodies that will be extensively deciphered during future Webb observations. Knowing that the exoplanet will soon become the focus of the Space Telescope, a team from the Hebrew University of Jerusalem, led by Professor Asaf Hochman, decided to do some basic theoretical work in advance. Specifically, the astronomers analyzed TRAPPIST-1e to work out a scheme that will help James Webb determine whether extrasolar planets are suitable for human habitation. As part of their study, the experts simulated the exoplanet's climate, focusing on how it responds to increases in greenhouse gases. In particular, they wanted to study the effects of carbon dioxide on extreme weather phenomena and the rate of weather change. When it comes to the question of potential habitability or the existence of life on alien celestial bodies, these two variables are fundamental, Hochman said. Together with his colleagues, he eventually found that TRAPPIST-1e's atmosphere is significantly more sensitive to greenhouse gases than Earth's. In other words, This means that increases in greenhouse gases in the exoplanet's atmosphere can lead to even more extreme climate changes than on our terrestrial home. At the same time, however, the research scheme developed by the scientists is also a pioneering pointer for the future. In combination with the observation data from the James Webb Telescope, the atmospheric composition of exoplanets can be studied more effectively than ever in the future. And all this without the need for a probe or even an astronaut crew to set off for the remote realms to study the real conditions on the ground, of course. However, based on such findings, we can also draw conclusions about terrestrial climate change and make predictions about how the Earth's atmosphere might change in the future. And now it's time for your opinion. What do you think about the fascinating discovery of TRAPPIST-1e? Do you think it's possible that the planet is actually habitable? Or possibly even already harboring extraterrestrial life? As always, drop us your thoughts, suggestions, and feedback on today's video in the comments. Don't forget to leave us a like and subscribe to the channel so you'll never miss any of our posts again.